Hello everyone. So we are going to solve Leetcode problem 3578, which is count partitions with maximum difference at most k. So let us understand the problem first, then we will move to the solution part. Problem is pretty simple. It says that you are given integer nums and k. You have two integer nums and k, and you have to divide nums into non-empty contiguous segments in such a way that in any particular segment the maximum difference and minimum difference, meaning a difference of the maximum and minimum element should be at most k. In this way, we need to find the number of ways we can partition nums, and since the answer can be large, we have to modulo with 10 to the power 9 plus 7. Let us take example, then we'll understand it. Uh, so this is an example provided 94137 k is equal to 4. So what are the possible number of, what are the possible ways of partition? See, we have to take the first element 9. 9 minus 4, if we take this element, it is going to be 5, which is greater than 4. So we cannot take 9 and 4 in one segment in any of our valid partitions. So we have to keep 9 separate at each partition. In all the partitions that are possible, 9 is separated. Now what are possible? 4 and 1, difference is 3. We can either take 4 or we can take 4 or 1, difference is 3, which is less than 4. Now if we take the segment of 3, then also difference of maximum and minimum is still 3, which is less than 4. So we can also take possible pair is 4, 1, 3. But if we include 4, 1, 3, 7, then what are the problem is maximum is 7, minimum is 1. So it is going to be 6. So we cannot take 1 and 7 together. So now let us see the varied partitions. 9 is always alone in all the partitions. Now apart from that, 4 is there, 1 is there, 3 is 7. We can take all the elements individually. Now let us start pairing. 9, 4, 1, 3, 7. We can pair 7, 3. That is possible because the difference is 4. Now we are pairing, we cannot pair 7, 3, 1. So what we can do is we can pair 3 and 1. Is it possible? It is possible because difference is 2 in this 9, 4, 1, 3, 7. We can do one thing, we can pair 4, 1, 2, 9, 4, 1, 3, 7, or we can take all these 9, 4, 1, 3 together and 7 different. So on all these pairs, we have difference less than 4. So now let us understand the approach. It is something a DP problem. So let us go through and understand what is the problem, how we can fix it, how can we can solve this. Let us write this 9, 4, and it was 1, 3, 7, right? So the approach is pretty simple. Like you have to take a DP array, and state of DP, it is a 1D DP, and in 1D DP, state, suppose DP of I represents, means how many elements we would have been, how many partitions is possible at the index I minus 1. It means DP of I means simply means I is the number of elements. You can take it as number of elements. So if we have taken DP of n, means if we have taken all the array, then how many possible partitions are there? If we have taken DP of 1, it means we have taken a single element 1, and then what is the possible number of partitions? So if you take the base case is DP of 0 is equal to 1. But first let us understand the approach of this problem. So the problem states that okay, so since it is 1D DP, now see, if we are deciding DP of n, what we need to find? For a particular partitions, we need to find where would have been the starting element. Means suppose this is a, this one, if DP of, we are finding DP of n, it is going to be our last subarray. But it is also possible that our last subarray should be from here. So we need to find the what is the possible value of, suppose we name a segment j to I. Yeah, that from j to I there is a segment. So we need to find that where is j, so that after that we can add the sums. Like j can end here, means the this, which is the subarray which is previous than the current subarray, which is last subarray. It can either end here, j here, j can end here, but j cannot end here at this point, because what is the problem? In that case 7 minus 1 will be in the one segment and it will be greater than 6. So we need to determine what is the value of j. So the brute force approach can be done in O of n square, it can be solved. And when we go for O of n square, what will happen is that it will exceed the time limit complexity. Otherwise, in going from O of n, what we can do, we can start iterating from I and check at what point what j are possible, and we can add all these things. But here comes the approach which should strike to your mind. There is, we can store a prefix array which can optimize our solutions. What we are doing, we are basically adding the DP of j for this point, right? So why don't we keep a prefix array which will be storing a sum of dp, and once we determine a suitable j, we can take that range of sum and we can store in that particular element. So it is a possible answer value solution. So now how we are building the prefix array? Prefix array is simply a sum of dp. Prefix array is sum of all the dps and of elements. Like dp of I, it means it is sum of prefix of 0 to prefix of sorry, let us take the prefix of I. So prefix of I means that it is sum of from elements, all the elements from 0 to I, right? So we are taking from 0 to I. Now what we are doing is, see, now what we need to identify the where can our be j, because if we can do, we can from the prefix array we can find in O of n what is the sum till that element. So for that approach we can use a sliding window approach. Like what we will be doing, we will be storing something a set or priority queue, both of which you can use. And what you can do is we will keep adding the element and we will check, like we are adding, we are at range here, suppose we are our I has reached here, we will add one and we will check if the minimum and maximum elements exceed k, we will reduce the j, we will bring the keep it reducing till the difference is less than k. Once our range is less than k, it means that suppose this is the range. So what happens that for this particular I, we need to add the element which is in this range, means we need to add the prefix for this one, 4. Now if we take 3, so for 3 what we need to do, we need to check the segment. If we take a sliding window, the best possible combination will be 413, this one. So we need to prefix, add the prefix of 4 and 1, right? So now let us move to the code, which is I have written Python code, and let us understand what is it. I have taken the length of number, then I have taken mod, which is required because number can be too large. I have taken a length of n plus 1 because I am following a 1 based indexing, and dp is also of length 1 plus 1 n plus 1. dp of 0 is 1 and prefix of 0 is 1. Prefix of 0 is sum till dp of 0, so it is going to be 1. And I have taken a sorted list, like it is an ordered set. Now I have taken I and j is from 0 based, following 0 based indexing, so from 0 to n, and j starting from 0. J is the first element of the sub array and I is the last element, which is possible. We add nums I in our sorted list and we compare with the first element and last element until the difference is clear. We are reducing the uh, this particular j, we are reducing the rent of the starting element, we are increasing the starting element, and we are removing it from our sub array. Now what is the case here? When we have reached here, j and I is the length of the segment, is the segment of that numbers till which our maximum and minimum difference is not exceeding k. So now what we can do is we need to add the j in this range. So we have to do, we have to add prefix of j plus 1 till prefix of I. So prefix of I we have taken dp of I plus 1 is equal to, we are storing for particular I indexing, we are storing in dp of I plus 1. So dp of I plus 1 is equal to prefix of I, means till we have to add till the prefix of, okay, so what is happening here is prefix also array is also following 1 based indexing, right? So let me show you. Suppose we are at this place, right? So we need to, so our I is here at this index. So what we have to do, we have to add all the i's till prefix of this one. uh, when I is here, i's value is 0 1 2 3. So we have to add the prefix till 0 1 and 2 and 3. Okay, so yeah, we have to take the i's till 0 1 2 3, whatever the prefix sum would be, will be till 3, because we can start from here also, our last element can be from here also. So what is happening is dp of I plus 1 is equal to prefix of I. dp of, we are at index 4, so we are storing in dp of 4 is equal to prefix of I, which means prefix of 3. So what we are doing, we are taking the elements till here, prefix of 3, we are taking the prefix till here, and then what we are doing is, if our j is greater than 0, means our range has our range has moved from the starting point, then we are subtracting that. So suppose our j is here, right? So what we are doing, we are, our j would be 1 here, so we are reducing from that prefix of dp of 4 is equal to prefix of 3 minus prefix of 0. In that case we will be adding the sum of dp of 1 plus dp of 2 and dp of 3. We are adding the sum of all the numbers. And after that, what we are doing is we are updating our prefix element by prefix of I plus 1 is equal to prefix of I plus dp of I plus 1, and we are returning dp of n. That's the solution.